Welcome to EDU World Space.
A reminder that the word bolometric, in terms of using it with magnitudes, means that a bolometer has essentially been used to collect your energy flow from a star. And a bolometer is a device. It's basically an absorber of radiation at all different wavelengths. And so bolometric magnitudes do not include a wavelength dependence. This will become important when we look at colored filters, which do have a wavelength dependence, of course. Here we're going to be calculating a 0 point of the apparent bolometric scale. And what we'll be using is the theory for the basically the solar irradiance of the sun. So we are using our sun as kind of a reference point for this system. So we are calculating a correction factor, C-BOL. Yes, all sorts of correction factors for magnitudes. So what we'll be using is the sun, and we want to use the apparent magnitude bolometric for the sun, which can be calculated from knowing how far the sun is from the Earth and knowing its absolute magnitude and using a distance modulus, for example. What is inside of the logarithm is actually the solar irradiance observed at the Earth. And we know what this is. It's a little bit weird to put something, a quantity with units inside of a logarithm. But we are just using this to calibrate the system more or less. And that solar irradiance is 1365 watts per meter squared. And so that is what we are going to use inside of our logarithmic function, 1365, plus the constant that we're trying to solve for. And this will give us an arbitrary number for this constant, but it is kind of like a 0 point or a shift. And so we can simply solve for that constant. It is minus 18.99. As far as I know, we don't actually ever use this constant for anything, but it is a arbitrary reference point in the bolometric apparent magnitudes.